How are you all? I hope you all are fine and safe. Okay, so after a long period of time, I came up with another integral, and this integral is I think it's not that difficult, but I personally find it something contradictory problem. Like, yep, I'm just gonna tell you why I'm saying like that, right? Okay, so let's just firstly look in this video. I'm gonna just solving with the method one, which is like I'm just looking at it a lot. Like everybody is like solving with this method only, method one, right? And my method will be method two, and I haven't seen anyone of those guys who solved this problem by method 2 like my method. So maybe I'm gonna solving this first time, but yeah, let's look at it. And the answer of both the methods contradicts each other. That's why I came up with this integral. Okay, so just beginning this integral by solving it with method 1. Say it is as I equals 1, sorry, I equals, so I equals, we have integral of cotangent of x over sine of x plus cosecant of x, right, dx, right? So yeah, just my first method is like this. Cotangent of x is cosine of x over sine of x, right? And we have in the denominator as sine of x, and cosec of x is like cosecant of x is the inverse, is the reciprocal, sorry, not inverse, is the reciprocal of sine of x. So it is like this. We have t of x right here. So yeah, our I is like this: cosine of x over sine of x time over sine squared of x plus 1 over sine of x. Now you can see that sine of x is gonna cancel out here, and we have dx right over here. So our I is now very simple, that cosine of x dx over sine squared of x plus 1, right? So now what I'm gonna just like you can think now what I'm gonna just let, like, yep, here I'm letting sine x as t, then our cosine of x dx is nothing but dt, right? Oh yeah, oh sorry, actually someone called me, but yeah, all right. Yep, sorry for that moment. Okay, so now our IB, integral of dt over t squared plus 1, like you can see right over here that cosine x dx it becomes dt. So we have cosine of x here, and this becomes dt with dxl, of course. So yeah, it's very important, it's a very easy integral. We have a standard it's a standard integral, and this is equals tan inverse, tangent inverse of t plus c. So I is just putting the value of t, which is tan inverse of sine of x plus c. So yeah, very good problem. It's not good, but very easy problem, I can say that after looking at this, right? So yeah, this was the method 1, and what I'm gonna do with method 2 is, let's begin. Yeah, so I have as I equals cotangent of x over sine of x plus cosine, sorry, it was cosecant of x, yep, dx. Yeah, so I know that, actually I know, I don't, but actually we all know that derivative of negative cosec of x is nothing but cosec of x times cotangent of x, right? I hope you all know that. So I'm gonna just use it. So like I as just letting cotangent as it is over there without any kind of disturbance, and sin x, I'm gonna write it as 1 over cosec of x plus cosec of x, right? We have dx right over here. So our I as integral cotangent of x over 1 plus cosecant of square x times this that like this denominator cosec of x will be right here multiplying with this, right? I hope that simple mathematics you don't get mixed up with. So this is cosecant of x dx. So now I can say that finally I can say that cosec x, like what? Yep, negative cosec of x is t. So now cosec of x is negative t, and differentiating both sides will give us 2. Like derivative of minus cosec of x is this. So yep, it is cosecant of x times cotangent of x equals, sorry, no, it was dx dt, right? So what we have is like sorry, it is minus dt, just because cosecant of like I'm just like sorry, yep, derivative of this thing is this. So yeah, it's not minus, actually it's positive. So no need to worry about that. So I as dt over 1 plus t squared, actually, so squaring both sides will just cancel out this negative, so don't need to worry about that, right? Squaring both sides will, it's positive, so you don't need to worry about that actually. So again we have tangent inverse of t plus c, which is tan inverse of t is negative cosec of x plus c. So I'm having two different answers. I got, like, I thought that I'm gonna have like these two things are equal, like this one and this one. I'm gonna write it separately, like according to my solving, tan inverse of negative cosec of x is equal to, like I'm just letting that c, both the c's are equal, tan inverse of sine of x. So if I'm canceling both sides, like tan inverse, like just removing both sides, so we will have minus cosec of x equals sine of x. And I don't think that there is any kind of solution with this. So then how I can say that this is equal to each other? And hence I'm solving this integral with my method and I'm having a trouble with this. This should not be like that, right? Just because, like, if I did something wrong, then please tell me. I don't think that I did something wrong over here, and I'm just here raising a question mark. Yeah, so that's all for today, and just tell me whether I did something wrong or not. Okay, thank you so much for watching this video.